Hello and welcome all my dear students. So in this video we are going to discuss about oxides and oxides of nitrogen. Oxides and oxacid of nitrogen. So first we will discuss about oxides of nitrogen. Oxides of nitrogen. So there are 6 types of oxides we are going to study. So I will make one tabular column. From that I will explain one by one. So first I will write name of the oxide, then formula, then oxidation state, then physical properties, then preparation. Okay. So the first member is nitrous oxide. First one is nitrous oxide. The formula is N2O. The formula is N2O. This is nitrous oxide. Now oxidation state. See, first oxide is, our topic is oxides of nitrogen. So the first member of oxides of nitrogen is nitrous oxide. Actually oxide, it means it contains oxygen. The compound contains oxygen. So we are calling oxides of that particular element. Here nitrogen is given, so it is oxides of nitrogen. So first member is nitrous oxide. Here the oxidation state, that is plus 1. Oxidation state is plus 1. How this plus 1 come? See, N2O, here how to calculate the oxidation state? We are calculating the oxidation state for nitrogen. So this oxidation state, that is this oxidation number, it is for nitrogen. See, N2O equal, how to calculate? So if any compound is given, so keep the value, the total value of the oxidation state equal to 0 for a compound. Then calculate the individual oxidation number. Here how many nitrogen atoms are there? 2 nitrogen atom plus, what is the oxidation number of oxygen? That is minus 2 equal 0. So 2 nitrogen equal plus 2. So don't forget, write the symbol, that is plus or minus. Then what is the value of nitrogen? Nitrogen equal plus 2 divided by 2 equal to plus 1. So oxidation state for nitrous oxide is plus 1. Okay. Let me make a column and then it will be easy. Hope you understood the how the oxidation state, here it is plus 1. Then physical property, colorless gas, it is a colorless gas. Okay. And it is a neutral. It is not, it is neither acidic nor basic. So it is neutral. Okay. Then one more important point, this nitrous oxide is called laughing gas. Laughing gas. நீங்கள் lower classல படிச்சிருப்பீங்க, சிரிப்பூட்டும் வாயுன்னு படிச்சிருப்பீங்க. So that is nitrous oxide. Next one is preparation. Preparation, it is prepared by the decomposition of ammonium nitrate. Ammonium nitrate formula is NH4 NO3. When it decomposed, it will give nitrous oxide N2O plus water. See here, hydrogen, oxygen, nitrogen is present. So when hydrogen oxygen combines, it will produce water. Remaining nitrogen oxygen is there. So we will get nitrous oxide. Clear? Now balance the equation. Hope that equation is balanced. No, it is not balanced. See, there are two nitrogen atom N2O and four hydrogen atom this side only two hydrogen atom. So add 2 here, then remaining 3 oxygen here, 2 plus 1 3 oxygen. So this equation is balanced. Actually I don't want to waste more time in the balancing equation because this balancing and all you know very well. So try. If not able to understand, then you call me, then I will explain. Okay. So nitrous oxide, formula N2O, oxidation state +1, it is a colorless and neutral. This nitrous oxide is called laughing gas. So the preparation is the decomposition of ammonium nitrate. This is ammonium nitrate. Ammonium nitrate. When it decomposes, it will give nitrous oxide, then water. Okay. So that's all about the first type. Then number 2, nitric oxide. Number 2 is nitric oxide. The formula is NO. Here calculate the oxidation state, that is keep NO is equal to 0. Then what is the oxidation state for nitrogen? N plus oxidation number for oxygen is -2 equal 0. Then N equal +2. So that oxidation state for this nitric oxide is +2. Okay. Then physical properties, it is colorless gas, and it's a neutral, not acidic, not basic. Okay. Now the preparation of this nitric oxide is, take sodium nitrate NaNO3, then add with ferrous sulfate, that is FeSO4, then add sulfuric acid H2SO4. Then the product will be ferric sulfate Fe2SO4 thrice plus sodium bisulfate, that is NaHSO4. This is sodium bisulfate plus H2O plus nitric oxide. Okay. See here, sodium nitrate, ferrous sulfate, this is ferrous sulfate, SO4 means sulfate. Okay. Then we will get ferric sulfate. This is sodium bisulfate. If it is Na2SO4, that is sodium sulfate. Here that is NaH. If hydrogen comes, that is bi. So sodium bisulfate plus water plus NO, that is nitric oxide. Clear? Okay. Now balance the equation. See here, this side there are how many nitrogen atoms are there? 1 nitrogen. So here also 1 nitrogen is there. When you balance the equation, then put 2 here, then add 2 here also, then here 3, then we will get here 2 NaHSO4, then 2 moles of water, then 2 NO. So check the equation. So try to balance the equations. Okay. So 2 NaNO3 plus 2 FeSO4 plus 3 H2SO4 gives Fe2SO4 thrice plus NaHSO4 plus 2 H2O plus 2 to NO. This is our product. Okay, these all other byproducts. So next one, that formula, this is N2O, this is NO. Next type of oxide, that is third one is Dinitrogen Trioxide. Third one is Dinitrogen Trioxide, or it is called nitrogen sesquioxide. So nitrogen trioxide or nitrogen sesquioxide. Okay, the formula is N2 dinitrogen N2, then trioxide O3. Tri means 3, di means 2, tri means 3, N2O3. Here calculate the oxidation state equal to 0. Then 2 nitrogen plus 3 into minus 2 equals 0, because oxidation number for oxygen is minus 2. So 2n plus minus 6 equal 0, 2n equal to plus 6, n equal to plus 3. This is the oxidation state for dinitrogen trioxide, that is plus 3. Oxidation state for this dinitrogen trioxide is plus 3. Okay. Then physical properties, it is a blue solid, the color is blue, then solid, and it is acidic, Okay. The preparation, that is NO, that is nitric oxide plus dinitrogen tetroxide, N2O4. Dinitrogen, tetra means 4. So when nitric oxide NO reacts with dinitrogen tetroxide, then we will get dinitrogen trioxide. Okay, NO plus N2O4, we will get N2O3. Balance the equation. Here add 2 here, then add 2 here. See here, there are 4 nitrogen on the product side, then reactant side there are 4 nitrogen, oxygen 6 oxygen on the reactant side, product side also 6 oxygen. So now the equation is balanced. Okay. Next one, nitrogen dioxide. Okay, nitrogen dioxide. Fourth type is nitrogen dioxide. The formula is NO2. Okay, see here, nitrogen, di means 2, so nitrogen dioxide, so NO2. Then calculate the oxidation number. The same way you are going to calculate, keep 0 for the compound, keep 0. Then N plus, there are 2 oxygen atoms, so minus 4 equal to 0, N equal to plus 4. So oxidation state for nitrogen dioxide is plus 4. Okay. Then the physical properties, that is colorless solid, and it is acidic. Okay. Sorry, it is not colorless. Nitrogen dioxide, it is actually brown color gas. Sorry, my mistake. Nitrogen dioxide is the brown color gas. I'm writing here. Actually, this nitrogen dioxide you already done in the practical. take any nitrate. When you heat the nitrate, you will get brown color gas. Okay, so that is the presence of nitrogen dioxide, brown gas, and it is acidic. ஓகே, அதாவது நீங்கள் ப்ராக்டிக்கலில் நம்ம டெஸ்ட் பண்ணியிருப்பீங்க. நைட்ரேட் எடுத்து நீங்கள் டெஸ்ட் பண்ணிங்கன்னா உங்களுக்கு ப்ரௌன் கலர் ஒரு கேஸ் வரும். அதுதான் என்னது, ப்ரெசன்ஸ் ஆஃப் நைட்ரேட். அந்த ப்ரௌன் கேஸ் என்ன வருதுன்னா நைட்ரஜன் டை ஆக்சைடு தான் குறிக்குது. ஓகே, ஸோ இட் இஸ் எ ப்ரௌன் கேஸ் அண்ட் இட் இஸ் acidic. Now preparation, take lead nitrate, that is take any nitrate, that is we are taking lead nitrate PbNO3 twice, then heat means you apply heat on the Bunsen burner, we will get nitrogen dioxide NO2. Actually in the textbook one mistake is there, that is given nitric oxide, NO is given, so that is a mistake. So change to NO2 plus lead oxide PbO plus oxygen. Okay, now balance the equation. Here put 2 here, then here 2, then there are 4 nitrogen, so put 4 NO2, then remaining here 3 oxygen. Okay, so 3 oxygen, 2. Now check the equation, that is balanced. Okay, so lead nitrate, when you heat we will get that is a brown color gas, that is NO2. It is a gas. Okay, the symbol is upside arrow. Okay, NO2 plus lead oxide PbO plus oxygen. So that's all about the preparation of nitrogen dioxide. Nitrogen dioxide, that oxidation state is +4, formula is NO2. It is a brown gas and it is acidic. Take lead nitrate, heat it, we will get nitrogen dioxide plus lead oxide plus oxygen. Then next type of oxide is nitrogen tetroxide, dinitrogen tetroxide, or you can say nitrogen tetroxide. Nitrogen tetroxide. Tetra means it is 4, so N2O4. Calculate the oxidation number, N to 2N minus 8. So how the 8 came? So you understood, equal to 0. So N equal to plus 4. Okay, so that oxidation state is plus 4. It is colorless and it is solid and it is acidic in nature. Nitrogen tetroxide, that formula is N2O4. Calculate the oxidation number, that is plus 4. You understand how to calculate. Then it is the physical properties, colorless solid and it is acidic. The preparation, that is take NO2 nitrogen dioxide, heat, then it will produce N2O4. So the decomposition of nitrogen dioxide will produce N2O4, that is nitrogen tetroxide. Tetra means 4 oxygen. Okay, so balance the equation, put 2 here. Now the equation is balanced, 2 nitrogen, 4 oxygen, 4 oxygen. Okay students, next type is last type, that is nitrogen pentoxide. Sixth one is nitrogen pentoxide. So penta means 5, so N2O5 the formula. Then oxidation state, keep 0, 2N minus 10 equal to 0, 2N equal to plus 10, so N equal to plus 5. So the oxidation state is plus 5. Then it is colorless solid and acidic. Okay, then preparation, we are taking this nitric acid, that is HNO3, plus phosphorus pentoxide P2O5. Then it will produce nitrogen pentoxide N2O5 plus phosphoric acid HPO3. Okay, balance the equation 2HNO3, then here put 2. Now the equation is balanced. Okay, check the equation, it is balanced. So nitrogen pentoxide N2O5, oxidation state +5, it is a colorless solid and it is acidic. Take nitric acid and phosphorus pentoxide, we will get nitrogen pentoxide. So that's all about the types of oxides. So there are 6 types of oxides are there. One is nitrous oxide, nitric oxide, then dinitrogen trioxide, nitrogen trioxide, then nitrogen tetroxide, then nitrogen pentoxide. So these are the types of oxides. Then formula it is given, then oxidation state also explained here, then physical properties, then preparations. So it is the very easiest types, you can understand easily. Okay. Now the structure of oxides of nitrogen. So we are going to see the structures of all the oxides of nitrogen. Structures of nitrogen. So the first oxide is, the name of the first oxide is nitrous oxide. Nitrous oxide. The formula is N2O. We are going to draw the Lewis dot diagrams. Lewis diagram, that is for N2O. What is the first rule for the Lewis structure? You have to count the number of valence electron. Number of valence electrons. What are the number of valence electrons? So nitrogen, that valence is 7. Nitrogen, the valence is 5. There are 2 nitrogen plus 1 oxygen. Oxygen valence electron is, that is 6. So 2 nitrogen, 2 into 5 plus 1 into 6 equal 10 plus 6, we will get 16. So number of valence electrons in N2O, that is nitrous oxide, that is 16. So this is the first step. Actually that Lewis dot structure is already you studied in class 11. Just take that class 11 second volume and refer that structures. What are the rules? Okay. So nitrous oxide, the valence electrons are 16. How the 16 came? Oxygen valence electron is 6. That is outermost shell. How many electrons are there? Because oxygen, that is 6th group, nitrogen is 5th group. So it has 5 electrons in their outer shell, oxygen 6 electron in their outer shell. So total 16 electrons. Now there are 3 atoms are there, 2 nitrogen atom and 1 oxygen atom. So write the least electronegative atom in the middle. So here compare with oxygen and nitrogen, nitrogen is the least electronegative. So write here in the middle nitrogen, then one side oxygen, another side nitrogen. Clear? Okay. Now second step, after counting this valence electron, this is step number 1. In step number 2, write the middle atom, that is the least electronegative atom, on both side remaining atoms. Okay. Now make single bond between the atoms. Make single bond between the atoms. This single bond contains 2 electrons each. So that means here 1 electron, here 1 electron, here 1 electron, here 1 electron. So total how many electrons? Total 4 electrons. So 16 minus 4, we have remaining 12 electrons. Okay, remaining 12 electrons. So these 12 electrons you have to distribute the corner atom equally. So that means it should reach the octets. Number of electron must be 8. So first step, count the valence electron. Second step, arrange that atoms. So the least electronegative atom in the middle, the remaining on the corner. Then third step, make a single bond between that atoms. Then fourth step, count the valence electron, and the fifth step, distribute the electron on the corner electron to get 8 electrons in each atoms. Okay. So now next step, 12 electrons are there. First fill oxygen, here 2, remaining 6. So it will get, oxygen will get 8 electrons. So 2, 4, 6, 8. Okay. So now 6 electrons distributed out of this 12 electrons. So 12 minus 6, 6 electrons are remaining. Okay. So from the 12 electrons, so I have shared here 6 electrons. So oxygen, here 2, here 6, total 8 electrons. So octet is completed for oxygen. Now remaining 6 electron, this 6 electron share in the that another nitrogen atom. So here 2, 4, 6. Now 6 minus 6, 0 electrons. So now there is no balance electrons. Clear? அதாவது நீங்கள் ஃபஸ்ட்டு என்ன செய்யணும் அப்படின்னா, லூயிஸ் ஸ்ட்ரக்சர் இன்னொரு வாட்டி நான் சொல்கிறேன். ஃபஸ்ட்டு இந்த வேலன்ஸ் எலக்ட்ரானை கவுண்ட் பண்ணுங்கள். அடுத்து லீஸ்ட் எலக்ட்ரோநெகட்டிவ் ஆட்டத்தை மிடில் எழுதுங்க. அப்புறம் ரெண்டு சைட்லேயும் ரிமைனிங் எத்தனை ஆட்டம்ஸ் இருக்கோ, இப்போ மோர் தேன் 2 ஆட்டம்ஸ் இருந்தால் மேலே கீழே அந்த எல்லாம் ஈக்குவலாக வர்ற மாதிரி டிஸ்ட்ரிபியூட் பண்ணிவிடுங்க. அதுக்கப்புறம் அந்த எலக்ட்ரான்ஸ் எடுத்து இந்த கார்னர் ஆட்டம்ஸ்க்கு வந்து நீங்கள் ஷேர் பண்ணணும். எல்லா ஆட்டம்ஸ் வந்து 8 எலக்ட்ரான்ஸ் இருக்க மாதிரி ஷேர் பண்ணணும். ஓகே, இதுதான் என்னது லூயிஸ் டாட் ஸ்ட்ரக்சரோட ரூல்ஸு. சி ஹியர், ஸோ திஸ் நைட்ரஜன் ஆக்டட் கம்ப்ளீட்டட், ஆக்சிஜன் ஆக்டட் கம்ப்ளீட்டட். But see here, this middle nitrogen atom, there is only 4 electrons. Okay, but 4 electrons are there, but octet is not completed. Clear? So we are going to complete the octet. See here, this 2 electron, this lone pair electrons can be converted to bond pair electrons. Lone pair can be converted into bond pair electrons. So here 2 lone pair electron can be converted to bond pairs. So what will happen? See, it is a resonance structures. So it will come nitrogen. So here middle already one bond is there. Then this lone pair will be converted to bond pair. Here also this lone pair converted to bond pair. Then nitrogen, then oxygen. Here 2, 4, 6. Here 2 electrons are remaining. Clear? So this is the now you check that structure, Lewis structure. For this nitrogen, 8 electrons are completed. See, octet is completed 2. So each bond has 2 electrons. So 6 plus 2, 8 electrons. This middle atom, nitrogen, that is 8 electron is completed. You see, here 6, here 2, 8 completed. Oxygen also 8 completed. Okay. Now the charge, how the charge will be applied? See, this oxygen is highly electronegative. Highly electronegative than this nitrogen. So here it will come minus, then here it will come plus. Okay, students. Now in this case, sorry, here, right here, this negative and this will be positive. Okay, after sharing this lone pair to bond pair, you will get this type of structures. Again it can, so how it can come? This bond pair can be converted to lone pair. This bond pair can be converted to lone pair. Also this lone pair can be converted to bond pair. So that final structure it will come like this. N, double bond N, double bond oxygen. Here 2, here 2, here 2, here 2. This is minus and this will become plus. Okay. So now you check that octet, this last atom, this nitrogen 8 electrons, middle atom 8 electrons, and this oxygen 8 electron. So that's all about the structure of nitrous oxide. Okay students, so in the next video we will discuss the structure of the remaining oxides. Thank you students.